Hi everyone! Today we are going to solve rational equations. In order to solve an equation that contains rational expressions, we'll use this step-by-step guideline. The first step states to factor denominators and or simplify each fraction. Our first example doesn't necessitate this. Step 2 says to identify the least common denominator. So in our first example, we see that our denominators are an x, an x, a 2, and a 2x. Therefore, our LCD is equal to 2x. Step 3 states to create fractions with like denominators. So let's obtain this common denominator that we've identified. In order to do so, we have to multiply the top and the bottom of the first fraction by a 2, multiply the top and the bottom of the second fraction by an x, and our fraction on the right side of the equation stays the same. So we will rewrite this equation as 2 over 2x plus x over 2x equals 3 over 2x. Step 4 states that we can eliminate the denominators on both sides of the equation. This is made possible because we've created fractions with like denominators. So by using the multiplication property of equality, we'll multiply each term on both sides of the equation by a 2x. So I multiply 2 over 2x by 2x, the x over 2x by 2x, and the 3 over 2x by 2x. This step illustrates why it's possible to eliminate the denominators at this point. So our 2x's cancel here, here, and here. In the next step, we will rewrite our resulting equation. So we really end up with a 2 plus x equals 3. Again, this was possible because we've multiplied every term on both sides of the equation by the LCD and eliminated the LCD. So from now on, we can skip this step and eliminate the denominators. Step 5 states to solve the resulting equation. So, when I isolate my variable, I'll subtract 2 from both sides, and I end up with x is equal to 1. The last step in our step-by-step process is to check the solution. So let's check to make sure that x equals 1 satisfies this equation. Meaning, when I plug 1 in for x, is it true that 1 over 1 plus 1 over 2 is equal to 3 over 2 times 1? Simplifying the left side, we've got 1.5, and the right side of the equation, plugging 3 over 2, we know that that's equal to 1.5 as well. Since 1 satisfies our equation, we can now verify that it is a solution to the equation. Let's try example 2 using this step-by-step process. Looking at our denominators, we want to make sure that we identify the LCD. In this case, our LCD is equal to 4n. The next step is to obtain fractions with like denominators. So we will multiply the top and the bottom of the first fraction by an n to obtain that 4n. The middle fraction already has 4n in the denominator. And the last fraction, we want to multiply the top and the bottom by a value of 4 in order to obtain a denominator of a 4n. Now, let's make sure that we rewrite our equation. So I end up with an n over 4n equals 1 over 4n plus, distributing my 4 through, I end up with a 4n minus 20 over 4n. Now, since I have all fractions with the same denominator, I can now cancel this denominator. So I'll rewrite my equation without this denominator. My resulting equation is equal to n equals 1 plus 4n minus 20. Now, let's solve our resulting equation. By isolating our variable, we can subtract 4n from both sides and combine like terms. The 1 and the negative 20 gives us a negative 19 on the right side, and on the left side of our equation, we have a negative 3n. Dividing both sides by negative 3, we end up with n equals positive 19 thirds. And last but not least, let's check to make sure that our solution satisfies our given equation. For the sake of time, I've plugged 19 thirds into our equation. And our result ends up that when we plug 19 thirds into our equation here, we end up with 1/4 on the right side of the equation. And since it's equal to 1/4 on the left side of the equation, we can verify that 19 thirds is certainly a solution. Using our step-by-step guideline, let's solve example 3. Our first step is to simplify fractions where possible and factor the denominators. Both are done. The next step is to identify our least common denominator. In this case, our least common denominator is equal to 6a squared. The next step is to obtain fractions with the same denominator. So let's obtain this LCD for all of our denominators. So let's multiply the top and the bottom of our first fraction by an a. Let's multiply the top and the bottom of our second fraction by a 6 in order to obtain the 6a squared. And let's multiply the top and the bottom of the fraction on the right by a 2a. Remember, our goal here is to obtain the same denominator of a 6a squared. 6a squared, 6a squared. Now let's rewrite our resulting equation. So we have an a over 6a squared minus 6 over 6a squared equals 2a over 6a squared. Now that we have an equation with like denominators, we may now eliminate that denominator. So by eliminating my 6a squares on both sides of my equation, I'll rewrite my resulting equation as a minus 6 equals 2a. Remember, we want to be mindful of this minus sign when we're subtracting rational expressions. Now, let's solve our resulting equation. We want to isolate our variable, so I'm going to subtract a from both sides to get that cancellation. And my next step will be -6 equals positive a. Then we want to verify our solution. I've plugged -6 in for a on both sides of my equation. Notice when I plugged that -6 in for a, I end up with -1 over 36 plus -1 over 36, which gets us -2 over 36, and then simplifies to -1 over 8. When checking your solution, you're plugging in your values to make sure that the left side simplifies to the same value on the right side. Again, I plugged a -6 in for a on the right side of the equation, and I obtained also a 1 over -18. Since -1 over 18 is certainly equivalent to 1 over -18, I can now verify that a is equal to -6 as our solution. Let's try this one last example for today. Notice I have two denominators on the left side, but the right side does not have a fraction. We still want to identify our least common denominator. In this case, our least common denominator is a 2b, and what we need to do in order to obtain like denominators on both sides of the equation is to multiply this 1 by a 2b over 2b. This way, when we rewrite our equation, we end up with a 1 over 2b minus b minus 3 over 2b, which is equal to 2b over 2b. Again, since we have our equation rewritten such that every fraction has the same denominator, we may now cancel this denominator of a 2b. Now, in the next step, we want to make sure that we distribute this negative sign into the b minus 3. So, our next step, we'll rewrite our equation to be 1 minus b plus 3 equals 2b. Now let's solve our resulting equation by isolating our variable. I'm going to add b to both sides, while at the same time combining like terms. So I have 4 on the left side set equal to 3b. Dividing both sides by 3, I end up with b equals 4/3. Let's verify that. Now, to verify that 4/3 is a solution to this equation, I plugged 4/3 in every single time I see b. So I simplify, and my resulting equation gets me 3/8 minus -5/8. Well, since that is equivalent to 1, and 1 is on the right side of the equation, I can now verify that 4/3 is certainly my solution to this equation. Now that we have done 4 exercises illustrating the step-by-step process for solving a rational equation, this completes our introduction to solving rational equations.
Made with Doodlecast Pro.